All right, guys, so we've worked with polynomials before. What we're going to be doing now is finding the sum, difference, product, and quotient of functions. So our four main operations, we're going to be doing them with any function. So similar to polynomial stuff. So here's what addition looks like. And in this first little section here, you're going to see some new notation. So very important to remember. So normally you guys are used to seeing like f of x and g of x. So we're going to start with two functions. Remember, this is just function notation. The x in the parentheses refers to the variable that we're using, and then the f and g just gives a name to the function that we're talking about. So here is how we write addition. We will have f plus g, and then we'll still have the x in parentheses. So whenever you see that notation, you know you're going to be adding those two functions together. So what it really is you just take your function f and then add it to your function g. And just kind of combine up like terms. Okay, so this notation means you're adding the two functions together. This notation means you are subtracting one function from another, so be careful with subtraction because order does matter. It means you're taking f of x first and then subtracting g of x, not the other way around. Multiplication, you will see f times g right inside the parentheses here, and then x is still your variable. So that is f of x times g of x. And then finally division, if you see f over g, that one represents division. So you would take the entire function f of x and divide it by the entire function g of x. This one has a very, very important domain restriction. You cannot have a denominator of 0. So with this one, whatever would make your denominator 0 needs to get excluded from the domain. Okay, so that's what we mentioned down here. If there are any restrictions in the domain and range, that'll only happen if you're dividing by 0. All right, so this will give you something that we call a domain restriction. Okay, so for this first example, we've got two different functions. Here's our function f of x. Here's our function g of x. So this first one says f plus g of x. So remember, that's the same as this. So I'm going to write that out first. So this is the same as f of x plus g of x. So all I'm going to do is I'm going to take my function f of x, right there, and then plus, and then take my function g of x. And adding literally means you're just going to combine up the like terms. So I've got, for my x squareds, I have a 3x squared plus 2x squared. So I can combine up those terms and I get 5x squared. I get 7x plus a negative x, so 7x minus x, and that leaves me with 6x. I don't have a constant here, so technically like 0 plus negative 1. So that leaves me with negative 1. So that is my new function that I got from addition. Let's see what I get from subtraction. So f minus g, again, I can just copy this down first. So it's my function f of x minus my function g of x. So really similar to what I did up above, just subtraction instead of addition. So copy down my function, but then minus. So with the subtraction, it's super important to make sure you have parentheses because you're subtracting this whole function, which means you're subtracting 2x squared, you're subtracting negative x, you're subtracting negative 1. So let's be super careful with that. So 3x squared minus 2x squared. That's going to leave you with just a single x squared. 7x minus negative x. So that's really like 7x plus x. So that would be an 8x. And then I technically have a 0 over here. 0 minus negative 1. So that's like plus 1. Okay, so that's what addition and subtraction looks like. Pretty straightforward. You're basically just combining like terms. Let's flip and look at the multiplication and division examples. So f times g, remember that's the same as f of x times g of x. So I'm still just going to keep my functions in parentheses. And then times x minus 4. So this is like foiling, basically, like super foiling. So I start with a 3x squared. You multiply the 3x squared first to the x. So 3x squared times x gives me 3x cubed. Then the 3x squared times the negative 4. So that gives me negative 12x squared. Then I move to my next term here. I move to the negative 2x. Negative 2x times x gives me negative 2x squared. Negative 2x times negative 4 gives me positive 8x. Then finally I move to the 1. 1 times x is just x, and 1 times negative 4 would be negative 4. So for my final answer, I'm going to combine up my like terms. So I just have the 1x cubed. I combine these two for my x squared, so that would be a negative 14x squared. Combine these two, I get 9x, and then that minus 4 is my only constant. So that is your new polynomial. Still no restrictions in the domain and range because there's no denominator. Denominators are the only issue with domain and range. Okay, now f divided by g, that looks like it should be like sort of crazy complicated, but all we're going to do is literally just put one of them in the numerator and one of them in the denominator and write it out like a ratio. Okay, so this is the same as f of x divided by g of x. I'm just going to put f of x in the numerator over g of x in the denominator. And remember, g of x cannot equal 0, so let's do a little side work for that. So x minus 4 cannot equal 0. So to see what x can't be, I'm going to add 4 to both sides. So this is my domain restriction. So this function, as long as I don't try to plug in a 4, because if you plug in a 4, you'd have 4 minus 4, which would be 0 in the denominator. I can have 0 in the numerator. That's something that you guys get mixed up with. You can definitely have 0 in the numerator, but you can't have 0 in the denominator. All right, guys, in this second video, we're going to learn about the fifth operation that polynomials can use, and that's something called composition of functions. Composition of functions basically means you plug one function into another function. So the results of one function are used to evaluate a second function. So it looks like this. We've got, this is the official notation f with like an open circle, g. That means f composed with g. What you're basically doing is taking f and then plugging in g of x. Okay, so if we work from the inside out, here's how it looks. So we start with some sort of value x. So any value of x you want, could be 2 or like negative 7 or whatever. So you take that value of x and you plug it into our function g of x. Okay, so you take x, plug it into g of x, pretty simple stuff so far. You're going to get a number when you do that. Okay, you're going to take that number and then plug that into f of x. And that's what you get. Okay, so you plug a number into g of x, then plug that into f of x. Okay, so I'm going to make a little note. So for right here, you plug a number into g of x, and then you're going to get a number from that. Okay, so then what you do is you take that number and you plug it into g of x. I'm sorry, I said g of x, I meant f of x. So plug that number into f of x. All right, so what it looks like if I give you functions. Okay, so if I give you functions, you can plug one into the other. So remember, we're still trying to find f of g of x and g of f of x. So let's start with f of g of x. So remember what that means is I'm going to take g of x and plug it into f of x. So my function f, look at what's on the inside here. Remember this old notation if I had like f of 3. That means I'd look at my function f and I'd plug in 3 everywhere I saw an x. So what this means is I'm going to look at my function f and I'm going to plug in g of x every single time I see an x. So that's going to look like this. 3 of, and instead of x, I'm going to plug in g of x squared, minus, instead of x, I'm going to plug in g of x plus 4. Okay, but now we do know what g of x is, so we can actually plug that in. So equals 3, so now g of x is 2x minus 1, so I'm going to plug that in. Then squared minus 2x minus 1, and then plus 4. Okay, so I do have some simplifying that I need to do. So I can square this, which means I write it out twice in FOIL. And then here, careful with the negative, so minus 2x, but then minus negative 1, so that's plus 1. Don't forget you still have that 4 tagging on the end. So now let's FOIL this out. Leave your 3 out front. FOIL 2x times 2x is 4x squared. 2x times negative 1, negative 1 times 2x, and negative 1 times negative 1. Okay, combine up a little bit over here. I can add the 1 and 4. Okay, so just about done. We're just simplifying here. So distribute the 3. I can combine these up to a negative 4, and then distribute the 3. Distribute the 3 to that 1. Okay, so my last step, I will be combining all these terms. I have a 12x squared. My x is going to be a negative 14x, and my constants would be 8. So that is f composed with g of x, if I plug one into the other. So that's this first one right here. I also need to do the second one. I need to do g composed with f. So that means I go in the opposite direction. I take my function g and I plug in f of x. So this function is g. Remember, every time I see an x, I'm going to replace it with f of x. So 2 times f of x minus 1. Okay, I'm going to replace this f of x with its actual value. So f of x is this guy right here. And don't forget about the minus 1 on the end, and I can just simplify that up. So 2 times 3x squared, 2 times negative x, 2 times 4, minus 1, and finally, just combine up those constants on the end. Okay, so that would be my final answer here. And since the video is already getting a little long, I am just going to skip over this problem.